Hello, algebra students. We're ready for section 6 of chapter 5, where we're going to be graphing inequalities with two variables. This is a picture to the right of your screen here. This is what our new graphs are going to look like. Of course, the first few problems here are review. We're going to save those for class time tomorrow. Let's start off with our new vocabulary. First, we need to talk about a boundary. We're going to have a boundary in these problems. A boundary is the line in a y is greater than mx plus b or y is less than mx plus b form. In other words, we're going to be graphing a line, except instead of it being an equal sign, it's going to be an inequality sign. So when you graph the line, that's your boundary. Now, your boundary is going to be a dotted line if it's greater than or less than, and it's going to be a solid line if it has the equal to. Then we're going to shade. This is what's the new part. We're going to shade above the line for greater than and below the line for less than. So if you're scratching your head saying, I don't have any idea what she's talking about, just write down the word boundary and know that I'm going to be explaining it as I work the problems. Now, a half plane. A half plane is what has been divided. The line divides a plane into two parts. So the line divides the graph into two half planes. Okay, a half plane when you have a solid line is called a closed plane or a closed half plane. And when you have a dotted line, in other words, this is a solid line, and this one, the line's going to look like this dotted. A dotted line, it's called an open half plane. So obviously, when something is closed or sealed, it's solid, no air gets in. And if something is open, even if it's not completely sitting wide open, but it's unscrewed, if we're talking about a jar, it's going to still allow air in. So an open half plane is not going to be a solid dot. And here are the steps. These are going to be our steps to solving inequalities with two variables. So let's start with the first example. I'm going to just temporarily pretend like that's an equal sign. If I needed to graph this line, my favorite form is y equals mx plus b. That's called slope-intercept form. So I need to isolate y. So I'm going to add 4x. So 2y equals, when I add 4x, positive 4x plus 6. Divide everything by 2. And y equals 2x plus 3. So if I were to graph this line, I would come over to my graph and I would find the y-intercept, which was 3, and my slope is 2. So I'd rise 2, run 1. You can also go -2, -1. So this would be the line if this was an old-fashioned graph the line problem. It's not an old-fashioned graph the line problem. It's an inequality. So let's go back and change our sign back to, let's erase the equal sign here so that we'll remember that it was a greater than symbol. So 2y is greater than, I divided by 2. Remember, if that had been a -2, I'd have to change my inequality sign, but it's a positive 2, so it becomes greater than. Y is greater than, and it's not equal to. So when you come over to the line that you already knew how to draw, because it is not equal to, now my eraser will not let me erase just parts of it, so I'm going to redraw my line. So instead of a solid line, my line should have been a dotted line. So let me make sure you can see that in green. That's what the real line for this inequality should be. It should be a dotted line, and I should shade everything where? Above. Why above? Y is greater than. Where does y get bigger? Y gets bigger above the line. Anything below, y is getting smaller. So now I'm going to shade the region above my line. Now if you want to extend that, whoops, it should be dotted, remember. So let's extend that to make our graph a little bit neater. So we're going to shade everything above that line. That's all we're doing. Well, let's see if I followed those steps. Number 1, put it in slope-intercept form. Check. Graph the line and form the boundary. So double check. I graphed the line and then I went back and talked about that the boundary should be dotted. Shade, which half of the plane needs to be shaded? Well, because it was greater than, I shaded above. Now, here's the last step. Use a test point 0, 0 to see if you are sure about your shading. So let's see, should 0, 0 be in our shading? According to my work, it should not be. So let's do our check over here to the side. If I plug in 0, if I plug it in either in my original problem or in my new equation, if I plug in 0, 0, 0 is y and 0 is x. I'm checking this point 0, 0. Plus 3. Is 0 greater than 3? No. If I plugged it into the original, 2 times 0 minus 4 times 0, 0 is greater than 6. No. So if it's not true, then 0, 0 is not part of the solution. So I agree with my shading. I think I've shaded it correctly because for 0, 0 to be a solution, these answers should have been yes. So that's what that last step is, just a way of checking to see that you shaded it in the right area. Pause the video right here and let's you try number 2 on your own, please. Without me, attempt number 2, pause the video, and then you can check it with my work. All right, here's what number 2 should look like. Now, if we do the 0, 0 test, let's do that right here. Here's 0, 0. If I plug 0 in for y, and 0 in for x, 0 should be less than 2. So 0, 0 should be in my shading. Same thing if I plugged it in here. 0 is less than 2 because you're changing this to 0. So I feel confident my shading is done correctly. Now let's move on to number 3 where we have, this is a typo. This should be 3x plus 4y. So again, I'm isolating my 4y, so I'm going to subtract 3x from both sides and divide everything by 4. So it's going to be a fractional answer. Y is greater than or equal to negative 3/4 x plus 1/2. So to graph this, I need to go up to just 1/2 right here. From 1/2, I'm going to go negative 1, 2, 3, and over 1, 2, 3, 4. So there's 1 point. Let's go up 1, 2, 3 to the left. 1, 2, 3, 4. There's my third point. And this time, because it has an equal to, it's going to be a solid line. And which way do I shade? Y is greater than, so my shading should be above. We can do the 0, 0 test. 0, 0 is not in my solution. 0, 0 is here below that below 1/2. So let's check. 0 is greater than or equal to 2. That is not a true statement. If I plug it in here, 0 is greater than or equal to 1/2. That is not a true statement. So 0, 0 should not be in the shading. So I feel very confident about my answer. Let's check your progress. And you do number 4 on your own. All right, when you turn over to the back, we do not have 2 variables for A. We only have 1 variable. So when I subtract 3 from both sides, I end up with 4 and divide by 2. X is less than or equal to 2 because I divided 4 by 2. All right, now remember what you know. If it's x equals a number, any number, then it's going to be a vertical line. That rule is still true even for inequalities. So come over here to 2. I know it's a vertical line. Is it a solid line or a dotted line? Well, it's equal to, so it's going to be a solid line. And am I shading to the right or to the left? Remember, y is not an issue here. Only x is an issue. X is less than or equal to 2. So my shading is going to be to the left. You can plug in the 0, 0 test if you want to. 0 is less than 2. That's true, so it should be part of our solution. Let's work the second one. If 5x is greater than, when you add 3, you get 20. Divide by 5, x is greater than 4. So again, it's going to be a vertical line. So that was at 2, 3, 4. This time it's a dotted line because it is not equal to. And it's greater than, so guess what? My shading is going to go to the right. So here is the key to solving inequalities. You get all of your terms on one side. If you have a y, you isolate your y. If you only have an x, you isolate your x. Then you graph the related function and see where it crosses, and you can always use a test point to check your solution. All right, sometimes we're going to have inequalities given to us in word problems, so let's look at this first one. Journalism. Eric writes and edits short articles for a local newspaper. It takes him about an hour to write an article and about half an hour to edit an article. If Eric works up to 8 hours a day, how many articles can he write and edit in one day? Now, you and I both know if he does a lot of writing, then he won't have as much time to do editing, and vice versa. He can do more editing, then he has to do less writing. So to the right is a graph of the inequality. X they've let represent his articles that he writes, and Y represents the articles that he edits. So when you look at the graph of this solution, all of these points inside are possible outcomes for this scenario. If 0, if he does not, X is for write. If he doesn't write any articles, then he can edit how many articles? So that's going to be 0, what? 16. That's how many he could edit. If he writes 4 articles, then it looks like he could edit 4 with time left over. If he writes 4 articles and he wants to use all of his time, then he could make 8 edits, because 8 would land on our line. So that also works because that's the equal to part. So there are many solutions all within this shaded region. Let's let you check your progress, and we'll save that to go over in class tomorrow. I want to leave you with some sort of thought-provoking, funny. Here's a mathematical pun, I guess you could say, that you see this time of year. But mathematically, there is something very wrong with this. Can you think about it and bring me your answer to class tomorrow? We're trying to make what Santa says, ho, 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 and a lot of times you'll see people write HO to the 3rd power. Mathematically, though, this is not ho, ho, ho. So let's think about that and talk about our solutions tomorrow. Have a great day.